Alright, so what I wanted to start off with, so I want to recap what we did last session. So this is a quick brainstorm just to revise on what we learned last session, because I packed in quite a bit of formulas and then a couple of tricks to remember your exact value. So let's start off with, actually I'll just call out names and you tell me what you remember. Adam, name me one thing you remember last session. Anything. What did we talk about? We did talk about exact values. We talked about the exact values for trigonometric ratios, and therefore we can talk about some examples right now. Let's have a look at an example. What is the sine of 30 degrees? Can I please have Sebi? Sine of 30 degrees. Just drawing your hand again if you remember. It's root of 1 over 2, which gives you a half. Good. How do you know? Your index finger represents your 30 degrees, so remember it was 0, 30, 45, 60, 90. Drop down your index finger. Count the number of fingers on your left. And there was one finger, so you can say root of the number of fingers is 1 on 2, which is why you have root of 1 on 2, which is sine of 30 is half. Let's do another one. Cosine of pi on 2, Percy. Pi on 2, which finger is that? Yes, that's your pinky, good. So it's on your pinky, 90 degrees. Drop down the pinky, and now I'm cosine. So count the number of fingers on the right-hand side of that pinky. 0, so it's... What is it? You said 0. Yeah. Formula is root of 0 over 2. Root of 0 is 0. 0 divided by 2 is not undefined. It is 0. Okay? Quiet down. Next one. Let's do a tan. Tan was slightly different. What was tan of 60 degrees? What's tan of 60 degrees? Can I please have Frankie? Root 3 is correct. Again, you're dropping down your ring finger and you divide the number of fingers on your left, which is your sine. Sine divided by cosine. So if you drop down your ring finger, it's 3 divided by 1, and then root that. So root of 3 on 1 gives you root 3. Okay. What's another thing that we learnt? So we learnt exact values. I taught you a short way on that. What else did you learn, Layla? Good. The only thing that you had to learn from those express learning from those chapters was applying chain rule to each and every one of these functions. You had e to the power of x, you had log e to the power of x, log e of x, you had y equals sine of x, you had y equals cosine of x, and lastly you have y equals tan of x. Let's go through again. What was the derivative of y equals to e to the power of x? Can I please have yes, Amir? Good. The derivative is itself. What about the derivative of log e of x? Can I please Murray? Good. So dy dx is 1 on itself. In this case, it is x, so it's 1 on x. What is the derivative of sine then? Can I please have Luke? Good, this is cosine of x. What is the derivative of cosine of x? Can I please have Jack? Negative sine of x, good. And then finally, dy dx, or derivative of tan of x, is what? Can I please have Rex? Tan of x. What is the derivative? Yeah, sec. Sec squared of x. But what is sec? What is that? What's the definition, David? Now sine over cos is tan. I want to know what sec of x is. So when I say SEC of x, what's the ratio again? Whoops. What's sec of x again? So if I just said find sec of pi on 2. Good, fantastic. Sec of x is equivalent to 1 over the cosine of x. Okay, so when you say sec squared of x, it just means 1 over cosine of x all squared. Okay, so that's what it means. So that means it's possible to solve out if you have, the second of pi on 3 or whatever it is. You just got to understand it's 1 over cosine. Okay? What else did we learn? Did we learn anything else? No. Yes, got that. Exact values. And chain rule. All right. Now I'm going to make up a problem. You're going to find the derivative for me. Okay, I'm going to try to make it slightly tricky. Y equals 2. Let's do 2 on 3 log e of x on 3. Let's go, find the derivative for me. What is the derivative of y equals to 2/3 of log to the base e of x on 3? Done a summary of what we did last session. We talked about applying chain rule to every one of these functions. We talked about how to find exact values using my hand method. Let's apply it to this one now. Remember, derive the inside, derive the outside. That's your chain rule. What has changed? These are the rules. These are the only things we know. Anything that's changed, that's what we're finding the derivative of. Inside, then derive the outside. Is everyone finished? No? Just to help you out in case you're stuck. This is your inside. Derive the inside. And then derive the outside. All right, let's check our answers. Deriving the inside, most of you should hopefully pick up that x on 3 is the same thing as saying 1/3 times x. So the derivative of this is just 1/3. Okay, so derive the inside should just be 1/3. It's like saying 2x. If I said 2x, derivative of 2x is 2. So then same thing with this one. Okay, no difference, it's just a fraction. So I should have the derivative of the inside is 1/3 multiplied 2. Now I'm going to find the derivative of the outside. So I'm going to say, all right, derivative over the outside, which I'm going to use the blue line here. This is log. And we said the derivative log is 1 over whatever's inside the current log. So it's 1 over x on 3. So I got 1 over x on 3. But don't forget that you still had 2 on third, 2 over 3 times that log. So it's also times 2, 2 and 3 times this. Now the only thing that's tricky about this in one of the exams, they put a negative somewhere as well, but in the exam is a lot of students can't do this. 1 over x on 3. Apparently that's very confusing to a lot of students. And they can do this part. So this is normally fine. They can say, oh yeah, well, that just gives you 2 on 9 multiplied 2, and then they get stuck here. They don't know what they're doing. All right? Another way of thinking about this is you're really just saying 1 divided by, because that's what that symbol means, divide, x on 3. Goes back to, primary school mathematics about division. Flip it around, becomes 1 times 3 on x. So technically it's just 3 on x. And if you do that, you should get your answer as 2 over 3x. Hands up if you got 2 over 3x. Alright, and hands up if you screwed up here. Alright, good. That means that I'm testing you. What I'm picking out is your common mistakes, and that's what the examiner is going to do at the end of year. So focus on those little things I'm putting out. Yes, Leila? Sorry, hold on a second. Boys! Shh. I can't hear Leila. Sorry? Yeah. Let's try, let's do another example. So let's say if I added on another, I don't know, let's do plus sign of x squared. How's that feel? Yeah? If we do that, if we found the derivative of this, we found out that was 2 over 3x, so that's okay, that's cool. Now you just find the derivative of this separately, because you can find the derivative of separate terms. In this case, we've got one term, which we just figured out. Now you find the derivative of sine of x squared. How do you do it? What's changed is your x squared. Derive the inside, then derive the outside. So deriving the inside, I'm going to use a different color so you can see. Derivative of x squared is 2x multiplied to the derivative of sine. Derivative of sine is cosine, but it's cosine of whatever's inside the bracket. So it's cosine x squared. So together, 2 and 3x plus 2x cos x squared. How do we feel? Good? Excellent. Now, product rule. Product rule, you would have learnt this last year. I'm just going to give you my rule, and so hopefully you remember it as well. Shh. Shh. This is the rule. Product rule, product means multiplication. Okay, product means multiplication or multiplying. So whenever you see where you have two separate functions multiplied to each other, that is when you use product rule. Okay, chain rule, when you use it, it's when you have a function within a function, or you can replace it. Or if you think about it, the way I sort of gave it to you before, I had a quadratic within a sine function. I had an x on 3, a linear function within a log. Okay, it wasn't log times sine, this is plus. So this is a chain rule problem for each one of them. Whereas a product rule is when you have two functions multiplied to each other. So an example would be y equals to sine of x times cos of x. Or if you want something a bit more straightforward, you know y equals x cubed, right? That is the same thing as writing y equals to x times x squared. True? So that means if we did the power rule, which we know do y dx of x cubed has to be what? 3x squared. Good. So we've got 3x squared. Now if you use the power rule, I mean the product rule, for this one, the answer should also be 3x squared. And that shows that you can use either one. But the point is, what I'm trying to show you is you've got x times x squared. That's a linear equation multiplied to a quadratic. You can use a product. You don't use chain rule on this one. Okay? You can actually use a chain rule for this one if you wanted to. You can say that's a linear function within a cubic. It's how you want to see it. You can see it as a function within a function, or you can see it as the product of two different functions. It's up to you. Okay? Now, the product rule, I want you to remember it this way. Okay? In the sense that it's VU first, so VU dash plus UV dash. Why I want you to remember in this particular order is because then it helps you to remember quotient rule. Okay? So, I want you to remember this, and how I sort of normally teach my students is I say it's Victoria University first before University of whatever. Okay, University of Victoria. So Victoria University first before University of Melbourne or whatever it is. Okay, so Victoria University first comes first, if that helps you. Okay, it doesn't matter at this point, but it matters when it comes to quotient rule. Because when you're adding, it doesn't matter which one you add first. But when it comes to quotient rule, it does matter which one you subtract first. And so that's why I want you to remember this way. The common thing that most students do is because it's u dot v, the derivative, they normally do uv dash plus u dash v. Okay, and so that's what I want to talk about. Now, the question is, what is u and what's v? U we denote as the first function, and v is the second function that you're multiplying to. So in our case, the example that I just gave you above, we call this u, and we can call that v. Okay, so those two are being multiplied to each other, so that's what u dot v is. The derivative, which is u dash means that derivative of u, plus u times the derivative of v. Okay, so if I actually tried to show you that if I'm going to use a product rule for this, it should actually equal to 3x squared. Let's try that. If I said let u equal to x, and then let v equal to x squared. So you see how I'm just calling this u and I'm calling that v? uv. So that's my x squared. U dash would be derivative of x, which is, what was it again? What's the derivative of x? 1. Fantastic, we got 1. What is the derivative of v, which is x squared? Good, we got v dash 2x. Okay, now according to this rule, they said v times u dash, and that's what I'm going to do. V, which is here, times u dash. Okay, so v times u dash, which is x squared times 1. So I'm going to write it out. So dy dx should equal to x squared times 1 plus uv dash, which is x times 2x. So I'm going to cross that, and so that's x times 2x. And let's see if it actually equals to 3x squared. Right now we've got x squared plus, that's 2x squared. And wow, look at that. X squared plus 2x squared gives me 3 groups of x squared. So product rule works. Okay, product rule here works, and it gives you a 3x squared you want. But what I want you to see is, it's when you have a function times a function. Sine of x times cos of x. Okay, it's different to this. See, that is a chain rule. It's sine of x within cosine of x. That's a chain rule, not a product rule. Okay, and it's key because at the end of year, it's going to be one of these two problems. Okay, you can either have a chain rule with a product with quotient with chain rule, or chain rule with other. I don't know which one it is, but it's going to be one of those three. Okay, out of those three, quotient, chain rule, and product, at the end of year, it's going to be 2 out of the 3. And that's like 3 to 4 marks out of 40. It's easy. Okay, it's easy for you to take in. That's why learn it, know the difference, so that you don't screw up at the start of your exam 1. Okay, it's predictable. It'll come up. It's 2 out of your 3. They're going to choose one of them, right? And they always do log, they always do sine, they always do cos. Sometimes exponential, just because it's ones that kids hate. They don't do polynomials. Anyways, how do we feel about that? Does that feel good? Yeah? All right, let's try. Whoops. How do I get out of it? Okay. Let's now try an example. So we got the rule. That kind of looks like that might be an exam question actually. That looks like I might have stolen it from an exam question. Have a go with this one. Differentiate x times log e of x. So you know your rules now. It's clearly a product rule because you've got x multiplied to log e of x. Do the product rule for me. Find out. I reckon that would be about 1 or 2 marks. I would say 2 marks if it was a generous question 1, I mean exam 1, most likely. Find the derivative. Sometimes they're generous. Exam 1, first 3 questions, they're generous with marks. Alright, let's check your answers. Hopefully you let the first function be u, so I called it x. I let the second one called v, so log e of x called v. Those are the two being multiplied. Derivative of x is 1, derivative of log e of x is 1 on x. And then we're simply doing our cross multiplication. Remember, it's VU first, Victoria University first, before University of Melbourne. Okay? So, we've got VU log e times 1, which is log e of x, plus you got x u v dash, so x times 1 on x, which we know x times 1 on x is the same thing as 1, so you should actually finally get log e of x, because log e of x times 1 is log e of x plus 1. Hands up if you got that. Fantastic, I taught you well. Now, try that one. I'm pretty sure this is an exam question. That's such a typical exam layout. You learnt your exact values as well, so use this as an opportunity to get your marks there. I'm pretty sure this is a 2 mark and there's probably 1 mark up here, so total 3 marks. How long should you have spent on question 1 in exam 1 of that year? I don't know which year that is. 3 times 1.5. So about 4.5 minutes to do both of these questions. Your aim is not to spend 4.5 minutes. Aim is to spend like a minute to 2 and move on. This is 2 marks because you get 1 mark for the correct derivative and 1 mark for the correct evaluation at x equals pi and 6. So the only reason why this problem's hard is because there's a fraction. It's just whether you can work with fractions or not. Six squared. Hands up if you got at least 1 mark so far. The derivative should be tan of x plus x times sec squared of x. That should be the first step, 1 mark. Second mark, this now works with your exact values and whether you can work with fractions, because sec squared of x is going to give you some sort of fraction. You got to remember, what is sec of x? What is the second of x? What is that equivalent to? I believe a second is, I'm not sure about this by the way, this is more of a special thing, I haven't looked at it yet. But a second to the circle is a chord from section to a section area.
I think maybe the one might be limited to
because 1 would be the radius, that's a unit circle. 1 divided by cos of x, which is 1 divided by the ratio of your x values over your hypotenuse. What are you measuring? 1 divided by... It might be an area. Anyways, here we go. This is what you should have started off with. Tan of pi 6, so hopefully by now you know tan of pi 6. That's your index finger, drop it down. Number of sine fingers divided by number of cos. There should be 1 and root 3 there. Plus, now that's pi on 6, which is your x, multiplied 2, and this is where it gets tricky. It's 1 over cos of pi on 6 all squared. Okay, so that's what I'm saying. I understand that a fraction, but you got to get used to it. This is a typical exam question. So the question is, what is cos of pi on 6 to begin with? Well, cos of pi on 6, again, is your index finger. Root 3 on 2. So I know this is actually the same thing as saying 1 over root 3 on 2. Now if this scares you, don't worry, write it out. Write out the mathematics, what it's saying. It says 1 divided by root 3 on 2. So you're going back to primary school mathematics, reciprocal multiplication. So 1 times 2 on root 3, which is just 2 on root 3. So you can put it all back together now. That is 1 on root 3 plus pi on 6 times 2 on root 3. Okay, see how I'm just breaking it apart. I'm not rushing it, I'm just taking my time. Oh yeah, I forgot to square it. Thank you. Well, I would have done a mistake right there. So this is divide squared. And I guess if I square that, that becomes 4 on 3. And that becomes 4 on 3. Thank you. Yes, there was a square there. Okay. And now let's just multiply it all together. So if we just write it out, derivative was 1 on root 3 plus pi and 6 multiplied to 4 and 3. Simplify it, that's 3 and that's 2. That gives 1 on root 3 plus 2 pi on 9. How I would also then do it is I'd change this to a rational number. So rationalize denominator times bottom and top by root 3. So you get root 3 on 3 plus 2 pi on 9. So therefore you can put it all together and say this is the same thing as saying 3 root 3 plus 2 pi all over 9. Okay? That's just because it's in the exam. I would try to collect it and simplify it together, keep the denominators rationalized. But that's just me. I reckon I can do that within 2 minutes, so I would do that. For you, I reckon if you had even gotten up to this step or that step, I don't think they would penalize you. Because as they said, rationalized denominator is not needed. Special you do, not methods. I do it anyway, just in case they do penalize me, then I'm still fine. It just looks nicer. Okay? Any questions on that? See, the only thing that was hard was just working with fractions and surds. Cool? All right. And did I rationalize? Oh, I didn't even rationalize it there. How about that? All right. Now this is what we just did was exercise 9J. That's product rule. You can have a look at these problems if you want. But what I just want to jump to, why I wanted you to memorize your product rule VU dash plus UV dash, okay? We try university first, because this is your rule for the quotient, okay? Write this down for your quotient rule. It's exactly the same thing, VU dash, but this time minus UV dash all over V squared. When do you use the quotient rule? When you have two functions that are dividing one another. So before it was times, now is divide. Yes?
Just use like the
Yes, you can. Sometimes it might not be. Yes. Then it becomes something like you don't want to do that. Yeah. Yeah. But if it's a polynomial, fair call. If it's a polynomial, you're right. Just bring it up. Do whichever. But most times if it's an exam, it's likely they'll force you to do this. So the question will be ugly if you use product rule. Okay? A quick example, tan of x. We said that the derivative should be secant squared. You can prove that. Tan of x by ratio is sine x divided by cosine of x. So if we're going to use the quotient rule, let's call u sine of x, let's call v cosine of x. The derivative of each one, we know from our rules. Then according to the rule was vu dash minus uv dash over v squared. So, here we go. Let's try that. We've got vu dash, vu dash. So that's right there, vu dash minus v dash, just sine x times sine x, which conveniently now gives you cos squared of x plus sine squared of x. And for those of you who learnt in Spec, that's a trig identity, or last year if you remember from Pythagoras' theorem. If this is cosine of x length and that's sine of x length, we know the radius is also 1 in a unit circle, so sine squared x plus cosine squared x is equal to 1 squared. That's why I know that is equivalent to 1 over cos squared of x. And that happens to be your secant. That's why secant of sec squared is equivalent to 1 over cosine squared x. Okay? But that's using the quotient rule. Easy? Alright, so those are your rules. You're going to practice 9J, 9K, but I'm more interested in this one. This is your exam questions. And I want you to do this one. Have a go. I'll show you how easy it is. So 2008, that was what? 6 years ago? 8 years ago. Not that long ago. No, more than 8. It's now 9 years ago. How about that? I'm getting too old now. 9 years ago. Exam 1, question 1. $5. Come come on, that's a giveaway. 5 marks out of 40. That's like 1/8 of the exam that you can technically do already. It's like, can you imagine that year, those students who couldn't do that? That's something you should be able to do. Everyone in the state will be able to do that. So you have to be able to do that if you want to get that 30. 30 onwards, you have to. 5 marks, question 1 of 5 has to be easy pocket. After that, you can start losing marks if you want, but try not to. Okay? Try not to. Exam 1's a giveaway. Yeah, such a giveaway. Look at that. 3 marks for B. That is no way a 3-mark question. It's just product rule and 1 mark for evaluating. That shouldn't be 2 marks, that should be 1. By now you should all be able to do that within 1 step. So that is totally giveaway that year. In terms of timing, if it's 5 marks, times it by 1.5. So you got about 7.5 minutes. Don't aim to spend 7.5. Pretend it's about 1 mark, and 2 marks should be about 3. 3 marks times 1.5, so about 4.5 minutes maximum. But you never try to do the maximum speed. You always want to minimize it so you get more time in the last few questions. 7, 8, 9, and 10, those are the worthwhile questions to do. Two marks. Remember, I told you, exam questions, factorize everything. If you left it in the second, actually if you left it as the first line, not good. I don't want that. I want you to factorize it fully. Notice again, I showed you, they always do it in exams. X squared minus 5x, 3x squared minus 5x, common factor of x. When you take it out, don't forget, it's actually to the power of 4, so take out that x to the power of 4. So if you remember, I'm just saying, if you factorize x out, you got 3x minus 5 to the power 4. It's to the power 4 to the power 4. That's why it's x4, 3x minus 5 to the power 4. Don't forget that. Every time you're in an exam, be specific, be careful, take your time. It's 2 marks. Okay, so while you're rushing, it's good, but don't skip steps. Take your time. Factorize it all out.
Not a week, like 3 days. Like,
All right, just before the bell goes, have a look at my solution to the exam question. Again, another common one, if it wasn't evaluating. Did I do something wrong? No. If you're evaluating, listening. For part B, because it says evaluating f-0, it doesn't actually matter if you factorize here or not, because you're just looking for that answer. So it's 1 mark for a correct derivative, and then 1 mark for the correct value. But if they don't ask you to find a value, I want you to get in the habit of factorizing every time. There's a common factor of e to the power 3x in both terms, take it out. It is a common factor, do it all the time. Okay? Because they do it in the exams all the time. This one?
Yeah.
So, using chain rule, derivative of 3x is 3 times the derivative of the outside. So derive e to the power 3x is itself. So e3x becomes e3x. So if you let u equal to 3x, then du